Okay, only two more examples. This is example 2, 4-2. So in this one, I have a coefficient of friction for kinetic, so it's moving. And I want to know the acceleration. I know the applied force is this 10 newtons. It is 10 newtons, yes. And the mass of the box is 10 kilograms. So let's do a free body. Let's take a look at this. That I have going down is my force of gravity. Going up is my force normal. See, I have this force applied this way. And I have this force of friction this way. Just remind ourselves that this angle will be 33 degrees. Cool. So it's asking for acceleration. That tells me that this force applied going in the x direction, so the x component of this that's battling the force of friction is winning. So that's the first thing to keep in mind. Second thing to keep in mind is what's happening to this normal. Remember one of the first examples that I did, I had you lifting a box or moving a box across the floor, and you're pulling a rope and the box is being dragged on the floor. Well, remember, you're lifting it up a little bit, so you're actually decreasing the normal. So as far as our friction goes, that decrease in the normal is going to impact how much you have to work to move the darn thing. Although you also have to be strong enough to lift the darn thing up. So I guess there's that. Let's see. Let's do our sum. So my sum of my forces in, let's go with the x. Go positive, positive. I'll have, let's see, my force applied. Let's see where my vector for the x lives. There is my x component of that force applied. There is my y component. Force applied y, force applied x. Can you see that? Make sure that you can. Force applied y, force applied x. There you go. So this is my x component. It is touching that 33 degrees. It is the adjacent side of that triangle. So force applied is the hypotenuse of that triangle, force applied times cosine of 33. Now, do I have any other forces? Yes, I do. I have that force of friction in the x. So minus the force of friction equals, well, it wants to know what the acceleration is, mass times acceleration. And I'm pretty confident in my choice of directions that it's going to be accelerating that way. And let's see if I'm right. So the forces in the y. Why do I need this? Because as soon as I see this and this thing is in motion, the force of friction equals the force normal times mu, because it's in motion. So my sum of my forces in the y, the upward, I have to find up as positive, is the force normal. Now I need the y component, because this is also in the upward direction. So if my force applied times sine of 33, minus, I've defined down as negative, so minus the force of gravity. This is not shooting up into the sky, it's not falling down to the ground. This sum is 0. So what does this mean? This means that I can now solve for my force normal. So my force normal is going to equal my force applied sine, whoops, I made that plus. Let me go back to why that's a mistake. This force applied is in the positive direction. That should have been positive. So this is positive. So it becomes force of gravity minus the force applied, sine 33. Now let's see why I caught on to that as being a mistake. Because when I first wrote this over here, I'm doing a motion of lifting something up. If this was negative and I moved it over here, I've increased the force normal. That would be like pushing a lawnmower or something where you're pushing down on it. That's how you increase the force normal. Well, I'm not. I'm lifting up on it. So if that's the case, then I had to decrease the force normal from the force of gravity. So I realized I had an error in my sign, and that's where the error happened. So it's really good to kind of pay attention to those things as you go. So now coming back to here, now we know what the force applied is. Sine 33, that's just the number. Force of gravity is just, let's rewrite that. Force of gravity is mass times gravity. So this is a known value. That's a known value. I come up here, that's a known value. I feel like I'm getting somewhere where I can solve for something. So I've been given the coefficient of friction. So let's make this substitution into here using this. So therefore, my force of friction, I won't skip steps on you, is the force of gravity minus the force applied, sine 33 times mu. Now I can put that into here. So I have my force applied cosine of 33 minus the force of friction. Well, now I figured out what the force of friction is. So minus mu times mg minus Fa sine 33. So that's that part. So what have I done? That's minus this. Cool. Equals mass times acceleration. Well, the thing I want is acceleration. So I'm going to skip a step here just to find my mass. Now all we have to do is put numbers in. So let's see. My force applied is 10 newtons. So 10 newtons times cosine of 33 minus mu is 0.03 times my 10 kilograms times 9.8 meters per second squared minus my force applied was this 10 newtons times sine of 33. Close that. Divide by the mass, which is this 10 kilograms. And that's what my acceleration equals. So I said something earlier. I said my hunch is that it's accelerating this way. It's probably accelerating this way because I'm applying a force this way. What I'm going to find out right quick is it, right? Because if I'm accelerating to the right, I've defined to the right as positive. So if this answer comes out positive, that means I am indeed accelerating that way. If this answer comes out negative, that means that friction is slowing me down, that I'm not pulling hard enough to keep it accelerating this way, that friction is slowing my motion down, and I'm going to come to a stop here right quick. There you have it. One more, you're almost there.